Today we're going to be talking about reflections. And our learning target is I can reflect a figure over the x-axis and y-axis and write a reflection using an algebraic representation. And the other part is I can use a symbolic representation to describe a reflection. So first, a reflection is going to be a mirror image of a figure. Okay. And a reflection does not change the size of a figure, so it's similar to a translation where it does not change the size, it just changes the location of a figure. We're still using the prime symbol to indicate that it's the new location of the point. And let's talk about what it does to the x and y. So here we have some examples of what a reflection would be like on the x-axis. So our x-axis is here, our y-axis is here. But let's talk about what the x-axis does. If you have a point here, the reflection on the x-axis will just jump to the other side like that. Same thing if it was here at the bottom, the reflection across the x-axis, it would just move it over here to where that's the new, your new x, right? Your new point. So when you look at when you have a reflection over the x-axis, your algebraic representation will only affect the y. Okay, and we'll see some examples here so it can make sense here in a minute. Okay, when you reflect over the y-axis, so let's look at the y-axis here. This is the y-axis. Let's say you have a point here, right? It's going to reflect over like here, and that will be your new point. Let's say this is A, this would be A prime, right? And then you wouldn't need these little lines right there. That's just to show you that it moved. Okay, so the algebraic representation for when you reflect over the y-axis is that you're going to put a negative in front of the x. And we'll see here in the questions, what does that mean? Okay, so first let's go ahead and draw a triangle ABC with the coordinates -7, 2. So we got, this one is A. Actually, let me put it in black. -4, 5. Is B, and then -1, 2 is C. And then we have that triangle. It says reflect over the y-axis. Graph the triangle A prime, B prime, C prime on the graph. And so what I'm going to do, this is the y-axis over here. Right here. Right? And so I'm basically reflecting all the points from the y-axis. So my C will be here, my C prime. My B prime will be right here. Right? And the way I got it is it's 4 spaces away from the y-axis, so I go 4 spaces away from the other side. Okay? For the A prime, it's 7 spaces away from the y-axis, so I'm going to go 7 spaces away as well. Okay? So it'll be right here. Okay? And that will be A prime. Okay? And so A prime was 7, 2. B prime is 4, 5. And C prime is 1, 2. Okay? So if you notice, like between A prime and A prime, the only thing that was different is the -7 and 7, right? It became +7. Same thing for the B. Only the x's changed. It was from -4 to +4, and C -1 to 1. All the y values, they stayed the same. So our algebraic representation will be this. We changed the x into a negative, and then the y stayed the same. So that's what we'll put for our algebraic representation. We put a negative in front, we basically changed or flipped the sign, and then y stayed the same. Okay. For number 2, it says rectangle ABCD was transformed using the symbolic representation x, y. It translated to -x, y. this is a reflection over the y-axis, because remember, everything that had the x, like in the previous question, all the x's change the sign. So if we have these points, let's see, A is negative 9, 10, B is negative 3, 10, C is negative 3, 1, and D is negative 9, 1, right? All we have to do is just change the x into a positive. So instead of negative 9, we just put 9, 10, 3, 10, 3, 1, and 9, 1. Okay, and let me show you here. A would be 9, 10. Be right here. This is A prime. B prime will be 3, 10. And then C prime will be 3, 1. And D prime will be 9, 1. Okay. And if you see, it basically just flipped over using the y-axis. Oops, there we go. Let's look at x-axis. So it's basically the same. The only thing is we're not going to do the negative with the x. It's going to be a negative with the y. So let's start with drawing our triangle. We got negative 7, 2 for A, negative 4, 5, and negative 1, 2. Okay. Now we're using the x-axis, and we're going to put it this way. Okay. So I'm going to see how far away I am from A. So I'm 2 units away from the x-axis. So I'm going to go 2 units away at the bottom, and that will be my A prime. My B prime, I went 1, 2, 3, 4, 5 units away. So I'm going to go over here at 5 units away from the bottom. And then same thing for C, 2 units away, that will be our C prime. Okay, and if you notice, they flipped to the bottom. Okay, our points, they ended up, A prime ended up being negative 7, negative 2, negative 4, negative 5 for B prime, and for C prime, it was negative 1, negative 2. And look, the only thing that changed was the negatives on the signs on the y value. So it was x, and then the y had that minus in front. Okay, so we can put x stays the same, and then y we switch away the signs, and the way to switch the signs is we show that it is a minus in front. Okay, so here we have a translation of a regular, and then we have a y there. So if the negative is on the y, that means that we have a reflection over the x. So it's always the one that doesn't have the sign. Okay. So for this one, let's go ahead and get our points. We got negative 2, 2, negative 2. For B, it's negative 2, 1, 2, 3, 4, 5, 6. Oh, that's a negative 2, negative 2. And then for C, we got 4, what is that? 1, 2, 3, 4, 5, 6. 4, negative 6, okay? And I don't have to do the reflection part on the graph. I can just say it's negative 2 and switch the sign on the y, right? Negative 2 and switch the sign on the y. And 4 and switch the sign on the y. Because if I use those points, I'll have negative 2, 2, so we'll have right here, that'll be my A prime, negative 2, 6, so right here that'll be my B prime, and 4, 6 will be my C prime. If you see, it reflected over the x-axis.